Hi, I'm Brian TYRRELL, the International Sales Manager at Val-Matic Valve, and I'd like to welcome you to the Val-Matic R&D Laboratory in Illinois, where we will be demonstrating two types of swing check valves in one of our water flow loops. Let's begin by having a look at the system. The Val-Matic flow loop consists of a battery of pumps that pump water from a 1,000-gallon storage tank through various test lines to a 400-gallon hydropneumatic tank, which we can pressurize up to 150 psi. Today we have the flow loop configured to do side-by-side check valve testing. The valves are mounted in two parallel pipes using the same type of pipe fittings so that they see identical flow and pressure conditions. The flow velocity will be measured using a digital flow meter. The pressure can be seen on the pressure gauge and will also be recorded using a pressure transducer and laptop computer that records the pressure 100 times per second. As we pump water into the closed tank, the water level will rise, compress the air in the tank, and increase the static pressure in the line. The first valve we're going to test is a 4-inch swing check valve equipped with external lever weight and air cushion. A conventional air cushion is designed to draw free air into the bottom of the cylinder and vent air out of the top of the cylinder as the valve opens. Then, when the valve closes, the release of the compressed air in the lower cylinder is controlled using a flow control valve on the bottom cylinder port. A conventional air cushion works very similar to the air cylinder on your storm door at home. As the door opens, air is drawn into the air cylinder. Then, when the door closes due to the force of a spring, the compressed air cushions the closure of the door so that it does not slam. The second valve we have is the Val-Matic SURGEBUSTER check valve, which has an internal disc accelerator or spring, and therefore has no need for an external lever, weight, or air cushion. The SURGEBUSTER works differently than the air cushion check valve. When the forward flow is stopped, the disc accelerator in the valve immediately begins closing the valve in a rapid manner. Check valve slam is caused by the sudden buildup of reverse flow after the pump is stopped, being followed by the sudden stoppage of that reverse flow by the check valve. We have learned that the faster the check valve closes, the less reverse flow, and hence the smaller slam. Now we will move on to the test. To demonstrate the effect, we're first going to pump water through the conventional air cushion swing check valve and into the hydropneumatic tank. When the pressure reaches 80 psi, a pressure switch on the tank will trip the pump. Then, in a fraction of a second, the air in the tank will stop the flow and reverse it rapidly back toward the check valve. Let's start the pumps. We can see the valve is opening and the flow is about 9 feet per second and pressure is building. And there we heard a significant slam. We just saw the pressure reach 80 psi, the pump trip, and slam the check valve close. Looking at the laptop results, the check valve slam produced a pressure surge of about 90 psi over the static pressure in the tank. Also note that the valve closing time was 0.67 seconds. The reason we heard a slam is because the water flow reversed and went backwards through the valve before it closed. Then, when the valve closed suddenly, it stopped the reverse flow almost instantly, causing the water handling. The solution to preventing slamming in this type of check valve is to get it closed faster before the reverse flow can develop. Unfortunately, a conventional air cushion tends to slow down rather than speed up the closure of the valve. This allows the reverse flow to increase. And then, when the reverse flow pushes violently on the disc, the air in the cylinder is compressed and cannot prevent the disc from rapidly closing, causing the slam. As we learned, the Val-Matic SURGEBUSTER check valve operates on a different principle that allows it to close faster. We will now pump water through the SURGEBUSTER check valve. Again, when the pressure reaches 80 psi, the pressure switch on the tank will trip the pump. Then, in a fraction of a second, the air in the tank will stop the flow and reverse it rapidly back toward the check valve. Now, let's start the pumps. You can see that the valve is opening and the pressure is building. And there we have silent closure. We just saw the pressure reach 80 psi, the pump automatically trip, but in this case there was no audible slam. Looking again at the laptop results, the check valve closure produced a surge of only 20 psi over the static pressure in the tank, which, as we heard, was virtually silent. Its closure time was 0.28 seconds versus 0.67 seconds for the conventional check valve. By closing faster, the SURGEBUSTER had no slam. We have just seen that the Val-Matic SURGEBUSTER check valve closes faster than a conventional air cushion swing check valve, which reduces the check valve slam. These check valve demonstrations mimic common applications in the field, such as when multiple pumps are used to deliver water or the pump station is being protected from surges with the hydropneumatic tank. In both of these scenarios, the flow reversal will be rapid and most check valves will slam. When using a swing check valve in these cases, it's beneficial to select the fastest closing check valve available, like the SURGEBUSTER. Thank you for your interest in Val-Matic products.